അതെ വലിയ പ്രശ്നമില്ലാത്തൊരു സാധന. 2 മണി തൊട്ട് 4 മണി വരെ. 2 തൊട്ട് 4 വരെ 5 ദിവസം. ഇതേ എപ്പോഴോ അടലിന്റെ ഒരു കോഴ്സ് അറ്റൻഡ് ചെയ്തിട്ടുണ്ടായിരുന്നു. അപ്പൊ അതിലുണ്ടായിരുന്ന ഏതോ ഒരു കക്ഷി ആ വാട്സാപ്പ് ഗ്രൂപ്പിലോട്ട് ഇന്നലെ ഒരു ലിങ്ക് ഇട്ടാണ്, ഒരു മെസ്സേജ് മീററ്റ് ഇൻസ്റ്റിറ്റ്യൂട്ട് ഓഫ് ടെക്നോളജി. നമുക്കൊരു കോഴ്സ് ആവും. അല്ല ഇത് മാത്രമേ ഉള്ളൂ കേട്ടാ. ജയകുമാർ എന്താ സ്റ്റാഫ് ക്ലബിൽ എന്താ ഇട്ടേക്കുന്നേ? ഓ നമുക്കിത് തന്നോ? ഫോം 16 തന്നില്ലല്ലോ. Hello. And uh-huh. എനിക്ക് മനസ്സിലായി. അവിടെ പോയില്ല എന്ന് തോന്നുന്നു. എന്തേ? അല്ല, നീ എടുക്കാന്നാ വണ്ടി. അല്ല, ഇതിന് എന്തായി? മറ്റേ ഇത് ടിക്കറ്റ് അവര് നാളത്തേക്ക് ആക്കിയോ? മറ്റേത് ക്യാൻസൽ ചെയ്തോ? അല്ല, പകുതി പോവും. പത്ത് പോവോ? ഇന്നിപ്പോ നിങ്ങളെ ഇന്നിപ്പോ എന്തായി? ഇന്നെന്തായി? ഞാൻ പറഞ്ഞത് നിങ്ങളുടെ വാക്സിനേഷത്തിനകത്ത് കയറ്റി വിട്ടിട്ട് പോവാന്. ഒരു മ്യൂസിയത്തിനകത്ത് കയറ്റിവിട്ടാ. മറ്റേ ഗ്യാലറിയൊക്കെ ഇല്ലായിരുന്നു അവിടെ? ഇനിയിപ്പോ എന്താണ് പരിപാടി?
ക്ലാസ്സിലേക്ക് അവർ പറഞ്ഞിട്ടേക്ക് പിള്ളേരെ പന്ത് കളിക്കുന്നു.
അവൻ നാളത്തേക്ക് വെച്ചേ. നീ വൈകിട്ട് വരുമ്പോ ഒന്ന് വിളിക്കണ്ടേ?
That is exploratory data analysis using the Python. So basically we would focus today most on the data pre-processing part before creating any final model or before the deployment of the model. What kind of things we have to taken in the consideration. So it's we'll start from the very basics to the basically I will end this sessions for that. Tomorrow we can say from where we can start it again, right? So it's a useful before creating a model. So all the things we have to process the same way. So that is exploratory data analysis. So as Khyati ma'am said that the prerequisite is already there, but if you have not done with that, so you can install the Anaconda software on your systems, and for that purpose, coding purpose, we need the Jupyter notebooks as we can say the tools where we can write up all the Python codes and all, right? So moving forward, we can start with some basic terms, and definitely then we would go for the hands-on where we can see how the EDA is useful basically for creating a model, right? So here, just we can define first exploratory data analysis, right? So basically we have seen, and we are also aware that whenever we are going in the field of data science or the machine learning, the first thing is the data, right? And day by day or in every hours we are generating a lot of amount of a data, right? So that all data is not necessary for us. First, we also have to do the analysis for it, right? So it's not like that if we have the 1000 records, so we are feeding 1000 records to our models, or the we can say for any real-time problems whatever we are solving, right? So first we need to do some data pre-processing with our data sets. So we would also focus on those pre-processing techniques, which is basically needed for the exploratory data analysis, right? So that exploratory data analysis is basically to see the various aspect of the data, right? Because everything is here data, because whenever we will train some models and all, so we also need some data sets. Basically in that terms, we also call it the past data, right? So past data, we would feed basically to the machine. So before feeding to a machine,
क्या पढ़ा रहे हैं इसमें बस डाटा साइंस अभी स्टार्टिंग
so I would request to all of you, please mute yourself if you have something, so you can also put in the chat window, or you can ask the same things, right? So basically that we are seeing that various aspect of the data before feeding it to directly to the machines for the learning or the training part as well, right? So that exploratory data analysis plays a great role where we are seeing the our data in a different manners, right? So that is basically the exploratory data analysis role, the EDA roles, right? Secondly, we have seen that in our data, we have a lot of things like we have the redundancies as well, right? So we have a lot of duplicate amount of a data as well, right? Or if we want to set some relationship among the variables, right? So because every algorithm which you will see in the machine learning as well in the form of regressions or in the form of other terms, so we basically finding the relationship among the variables, right? So if two variables or the two features are important to us, so we would keep it with our data sets, else we would either drop it or we would do some treatment with that, right? So so through the EDA, basically what we are doing, we are also removing the duplicacy, and we are also seeing the some relationship among our variables as well, right? So in this way, you can see that EDA process simply if we divide, so we can divide it into the three phase, that is understanding of the data, right? So we would just gather our data sets and all, right? We would see how basically what kind of a data it have, right? And once we would see our data, so definitely we would do some cleaning in the sense of we will deal with the null values, missing values, right? Or maybe some outliers in our data sets as well, right? So that kind of a things we would put under the clean the data. And thirdly, we can see the analysis of the relationship between the variables, right? So variables in the sense of, you can say in your data sets, if you have the 10 columns, so we can consider each columns as a variables or as a one feature, right? So we would also see the relationship among the variables. We would see how tightly they are correlated with each other. If there is a much more correlation, so we can also think about to drop out those columns as well, right? So basically this is the analysis of the relationship between the variables. So generally we use a lot of libraries in the Pythons for that purpose. Basically that are the visualizations library we have, that is Cbons or the Matplotlib, right? So they have their some advantage and disadvantages as well, right? So basically in these sessions, I would most probably use the Cbon library because it has its advantages, right? So it's built on the Matplotlib. It's just you can say the advancement of the Matplotlib because it's do not focus on the data frames always, right? So no need of always the data frames to plot some graphs between the variables, right? So this is one of the advantage of that Cbon library as well, right? So now we can go step by step. First of all, what basically we need to do whenever we are doing the exploratory data analysis. So here you are seeing these are some basic terms which we will do whenever we are doing the exploratory data analysis, right? So definitely the first thing is that getting the data sets. If we have our proper data sets, so we can apply that analysis on that data, right? So definitely again we need some libraries, so importing those libraries properly and the installations of those libraries necessary before processing further, like other programming languages we do, right? And then importing the data sets, definitely to process it we would read that data sets. So and if you are using it from some existing, we can say the like scikit-learn and all, where it's already predefined. So from there we can directly import. But if you have in those we can say the data sets in your system, so we can read those data sets as well, right? And one more term, that is taking care of missing data, right? So that is the most important thing, how we can deal with the missing data. Next, we have to deal with the encoding, right? So we have to do the encoding with our data. So encoding, basically, we would also go into the deep on that encoding part as well, right? So basically, what happens whenever we have the string values in our, we can say the data sets, right? So with that string values, we can't process it further, right? So we need to convert that either into integer or the binary equivalent so that our systems can process it, right? So that encoding scheme is useful there, where basically we are using that, we are dealing with the string values and all. And this is again the splitting data sets into the training and the test part. So that is needed whenever we would train our model. So we would also do that kind of a things. We would split our data sets as well. And one more thing is that feature scaling. That is also very important, because what happens in our data, all the values are not in the same proportion, right? So if we will compare age with the price, right? So age may be maximum 100 to 120, but price can be anything, we can say, right, in the lakhs, on the thousands, right? So we also need to do the proper scaling of those data so that our models would not be biased towards the only one feature, right? So it can also utilize the same things for from all the features whatever we have selected using the EDA processing, right? So these are the some things. So we would go one by one, and this is the first session. So I would also going to recall some basics and all, right? So that is necessary from tomorrow onwards, that your systems is ready with that to create any models. And if you have not done that, so today you can also do the things, that libraries and all, whatever is necessary for the upcoming days as well, right? So first of all, that I have said that we need a data sets, right, for which basically we would process that EDA, right? So these are some, we can say, the repositories from where you can get your data set. So most popular generally from where we take that for our practices, that is Kaggle data sets, right? For novelty purposes, we also create our data sets by on, right? So if we are doing on some projects or we are solving some real-time problems, so it's generally advisable that we create our own data sets as well. But for practice point of view, Kaggle datasets is there, scikit-learn dataset is there, and the UCI machine learning repository is there, right? So from where mostly you can take your data, any datasets you can take. If you are not able to find some datasets, so different Google, we can say the cloud platform has also provided some datasets there, right? Like AWS, Google, or Microsoft, their own tool is also there for solving such kind of a problem, right? So these are some other repositories from where you can collect your data sets as well, right? So basically, for practice point of view, Kaggle and scikit-learn is sufficient, but based on your requirements on the, or the projects or the problems, we can also go for another repository as well, right? So this is some of the repositories from where we can collect the data. Except that the second step, we need to import some library. So before importing those library, what kind of a library we need, right? So simply one thing is that numpy. So whenever we are doing some numerical operations, so we need that numpy, right? So you can install those library on your conda distributions, or if you are using simply Python, so you can also go with the pip install, right? So this is the numpy. This is the first library whenever we will deal with the array and all. So we would go with that, right? So this is our first library, numpy. Except that you need to install that pandas library as well. So if we are reading the CSV files, right? So for reading the CSV files, we would read that file in the form of frames, right? Data frames, right? So entire CSV files would be read in a single variables, and we would use the different data frames to access the different columns of that particular data sets, right? So this is basically useful for data cleaning and fast analysis, we can simply say. And for that purpose, again, you need to install, if you have Anaconda installation, so you can just install it. Conda install pandas in your Anaconda command prompts, right? So this is the second library which we need to install on our system. Third library we need, that is Matplotlib. So this is again for the visualizations point of view, to analyze the data. So we have that Matplotlib, but I would prefer, rather than that Matplotlib, we also have to install that Seaborn library, right? So the command is same like conda install Matplotlib and the conda install Seaborn, right? So that advantages I have already said, that we can also use that Seaborn library without any data frames and all, right? So this is the advancement of that Matplotlib, that Seaborn library, right? So definitely it has some more interactive visualizations as well, rather than we do in the Matplotlib, right? So one more thing regarding the Matplotlib, whenever we use it into the Jupyter notebook, right? So we include one line, that is Matplotlib inline, right? So basically we see that whenever we will do the coding on the Jupyter notebook, so the output cell is just below, right? So if you are seeing the output just below, right? So that in the Jupyter notebook, so that's why we include always whenever we are dealing that Matplotlib, right? So we use one line, that is Matplotlib inline. But generally, whenever we got our visualizations in a different window, right? So like if we use the spider, right? So this is also under the Anaconda distributions we have, right? So we use their plot.show command simply because it's from the visualizations in the different window, right? But in the case of Matplotlib, if you are working with the Jupyter, so that's why we use one actual line, that is Matplotlib inline, so that we will see. But this is just for your knowledge purpose before starting the hands-on and all, right? So this is the another library which we need to install, except that we also need to install the Seaborn library that would be installed in the similar way, like we installing the Matplotlib or the other library, right? So next, what we have, right? So we have already discussed about the encoding scheme in the for the pre-processing, right? So encoding, you can see here that if we have some columns in our data sets in the form of strings, right? So there is an animal column in our data sets and it is in the form of a string, right? So now what we need to do, we need to encode it into the binary, or we can say into some integers value, right? So if we are going for the one hot encoding scheme, so you can see here that each of the we can say how it is basically converted into the, we can say, the binary vector, right? So this is very simple. If you roughly want to estimate that what would be the binary equivalent value, so simply like we have converted our column into the form of row, and whenever we are finding that like we want to convert for dog, so we will simply put here 1 and rest of the columns are 0, right? So in this way, basically we are converting it into the binary equivalent value, right? So that one hot encoding scheme is useful, right? So like in our data sets, maybe some state column or the gender column or something like that. So we need to convert that string value if it is useful for us for the pre-processing part, right? So similarly, we have that dummy encoding scheme. So you can see here in one hot encoding, suppose we are converted ABC into the 100010001 in this way. Suppose we have the three category and we have mentioned the code in that way. So in that dummy encoding, basically it eliminates the we can say one of the column out of that, right? So if I drop the last column out of it, right, from each of the equivalent, right? So you can see that we have three unique value, right? Like 10, 01 and 00. If you will put starting 2 bits, so still we are able to differentiate that ABC, right? So in dummy encoding, generally we drop that kind of we can say the values, and still we are able to do the differentiations among the that three variables and all, right? And the third scheme, generally we use the label encoding scheme. So what happens in the label encoding scheme, basically it gives a value to the each item, right? So here we have the yellow color, right? So it mentioned for the yellow, we can say the 1, right? So again, the yellow is repeating, so it would convert it like an integer, so 1. Again, new color is come, so it is now 2. Yellow is already defined, so it's 1. So based on their, we can say the different color, we are getting some labels for that, integers value for that. So this label encoding basically useful for the final output, right? So whenever we have some category, we want to predict our data into a certain category, right? So we have some, we can say the define labels 0, 1, 2, 3, right? In that way. So that label encoding is basically helpful for that purpose also, to define our final output and all, right? So this is our encoding. So basic thing is that whenever we have the string value, so we would use that encoding schemes for our data before processing it, right? So this is our encoding scheme. The another terms we have, that is feature scaling, right? So this is also important, and I have already discussed these things in the starting as well, right? So in the feature scaling, what happens, like you are seeing the 2 columns here, weight and price, right? So weight has the we can say the larger value as compared to the price, right? So its price have the maximum value 5, but its ranging weight is ranging in a, we can say the have the margins between these 2 columns, right? So we need to convert these value into the same scale, right? So to do so, we have basically the 2 techniques as you are seeing here. One is that standardizations, and one is that normalizations, right? So that standardizations and normalizations basically we use to scale our data into the, we can say the same scale, right? So if we go a little bit mathematics on that, so you can see that if we have that 5 numbers, right? So to calculate the standard deviations, generally we need a mean, right? So we have calculated that mean, the average of all the values, right? So then what we do, from each item, we are just subtracting that mean value, right? So that is 3 minus 4, that is minus 1. Similarly, 3 minus 4, that is minus 1. And that in that way, similarly, we are doing for all the items. So we have subtracted that mean value from each of the item, right? Then we are doing the squaring of all these difference values, right? So minus 1 square, minus 1 square, the similar way, the 2 square, that is 4, right? Then generally what we do, we just add it, and we divided it by the total number of item, right? So the sum of this, that is 6, and we have the 5 item, that is 6 divided by 5. So we would get here 1.2. And finally, we do the square root of it. So if you will do the square root of that 1.2, so that standard deviations comes, right? So now how we are converting these values into the, we can say the standard value. Suppose you want to convert that 6, you want to standardize this, right? So that item minus the mean upon the standard deviation. So definitely you would get the converted value, the standardized value, right? So this is the standardizations, and generally doing the standardizations whenever we see, so it also covers the negative sides, right? So generally we take the value in the -3 to 3, right? But in the case of normalizations, this is other thing, other scheme to normalize the data. You can see here, this is excise the item, right? And we find the minimum, and we find the max, and we find the minimum. So whenever suppose we want to convert it for that particular data 1257, I want to normalize that particular 5 using the normalizations scheme. So my value is 5. So I would do subtract the minimum value. So minimum value is 1, right? So that's why 5 minus 1 divided by maximum minus minimum. So maximum is in this data is 7, and minimum is 1. So you can see that this is the 2/3. So whatever the value we have by dividing it, so this is the normalized value. And if you will observe this formula, so that normalizations would always give us a positive value, right? Because from that item we are subtracting the minimum value. And again, in the, if you will see here also, we are doing the maximum minus minimum, right? So that basically normalizations is helpful wherever you are thinking that your data have the only, we can say, the positive side distributions. It contains only the positive values in the sense, so you can directly use their normalizations. But if you are not aware about that, wherever our data is distributed, so you can go for the standardizations, right? So that normalizations basically converting value generally 0 to 1, right? So these are the two techniques which basically we use for the feature scaling part, and according to that we convert our values to put our features into the same scale. So that is the feature scaling. So now it's a time of hands-on, because we have discussed some basic concepts regarding that, whatever we basically need for that purpose, right? So I have taken one data set in the form of that CSV file. So we would start our that sessions with the CSV files. Definitely for upcoming, we would also go with the image part as well, right? So we can start from that CSV, and I have a that data sets which basically it's for denoting the company profits, right? So no, in these data sets, this is only country age, but we would also use that we can say the company profit data set. We would do the analysis, right? So what I'm doing, I am just putting into the chat window, I am just attaching that data set, so you can also take that data sets from there, and you can also do the same things parallelly with me. So for that purpose, I am just attaching that data sets. So I have attached it with the name of that 1000 companies, right? So basically this data sets denotes the records, 1000 records this data have. So I believe all of you have got that data sets. Can you all please confirm once, so that we can go for the hands-on part? Okay, so I would request please download that data sets for that activity part. So we would use the data sets, and before using that we would also see what kind of we can say the data it have, what kind of a pre-processing we need to solve before creating a model for it. So for that data sets, I have already shared the that CSV files with you. There is no link till now for it, so you can directly download it from that chat window. Okay, so most of us have got that data set. So now, first of all, what we can do, we can go inside that data sets and we can see what kind of a records we have under that. We can say the 1000 companies.csv files, right? So you can see in this data set, basically we have the some, we can say the features, or we can say some variables based on which we would determine something in the future, right? So what are that? There is a one column that is R&D expenditure, another is administration, third is marketing spend, and fourth is estate, and based on that we have a final column that profit. Because for any companies, if that company want to earn the profit, so based this data sets contains these categories. Basically based on that we are going to decide whether how much profit would be for that particular company, right? So that profit predictions is not a motive for today. Our motive is to that to see or to analyze the data, how we can visualize and can draw some meaningful aspect out of that data. So basically that is the EDA part, right? So we can see here, if we would analyze our data set, so it have almost 1000 records, right? So if we would go on to the bottom, so we have 1001. So first one is for our basically the label, right? So that's why we have total 1000 records. So initial practice, that data set is sufficient to see the different aspect out of it, right? So some of us still not received that data set. So I am again resharing it. So you can check it again. So I have attached it again, right? So this is our data set basically, and we have to do the operations with that data sets only, right? So you can see a lot of large values are with these data sets, right? So it's not easily readable, right? So for readability purpose, so the existence of that, we can say importance of that pandas library comes. So we would operate this data set with the help of that pandas library, right? So if you have the Jupyter notebooks with you, so you can also open a new Python notebook from here, right? So we can give some title to our that we can say the notebook, right? So I am just putting here profit analysis. Right, so this is basically our notebook for profit analysis to check the profit and basically for the different companies, right? So now we can go step by step with our data set part, right? We can say the EDA part, right? So first of all, the thing is that we already got our data sets, right? So now the next thing is that we would import one by one all the libraries, right? So if we would want to import the libraries here, so first library we have discussed, that is NumPy, right? So we would import that library as a NP. The shortcut name is NP for that. That is NumPy library. The similar way, we would go for the another library, that is we can say the Matplotlib. So before that, installations is needed for that purpose, else you would get the error for that, right? So that is pyplot as PLT, right? So whenever I need to call that Matplotlib library, so we would use it with the help of that PLT, right? So this is our second library which we need to use, that is Matplotlib, right? Another library we have, that is import, we can say the pandas, because we want to read the entire CSV file into a single variable using that pandas library. So we need to call that pandas, right? And definitely for more effective visualizations, I am also going to use that Seaborn library, right? So we can write here Seaborn, and we can refer it with the name of that SNS, right? So whenever we need that Seaborn library, so we would call it with the name of SNS, right? So I hope till now we are on the same page, right? Can you all please confirm once to me? We are on the same page. Okay, so now we can check the all the libraries, right? So whether we have successfully imported or not. So just run this cell. That is again the spelling mistakes is there, right? So instead of that, we need to write Matplotlib, right? So we can run it again, and now all the libraries are successfully installed there, right? So next thing is that once all the libraries is installed, now we have to read our data set, right? So for reading that data sets in the Python, we use the read CSV functions, right? So what I'm doing here, I am creating one single variable, that is companies, right? And in this variable, I would read our entire CSV file with the help of pandas library, and I would call that CSV function, right? So in this brackets, we need to define the entire path of that CSV file wherever you have downloaded that file, right? So here we need to define the entire path for that file. So you can also paste your path wherever you have pasted that, we can say the you have downloaded your data set. So for me, it's on my desktop. So I am taking the desktop locations from there. So you can see here, this is the complete locations for my data set, right? So this is basically the path where I have downloaded my data sets. So this is basically this need to be given there uh, for the reading purpose, right? So now what we can do, we can just run this cell again, right? And we can check whether we have successfully read or not our that data set in a single variables, right? To check, we would also find out some initial records, and we would can also print some bottom records from this data sets, because we have already read it into a single, we can say the variables, right? So to do so, if you want to print the starting 5 records out of your data, right? So instead of it using this companies wherever our entire file is there, right? So we can use the head function, right? So this is through this we can print this top, we can say the 5 rows of our data, right? So you can see here starting 5 rows, we can see here properly in our data sets, right? So this is possible through that head command, right? So similarly, to check the bottom records, we have the tail command as well, right? So we would use tail command for that. So instead of head, what we would do, we would just use the tail command here instead of head. So it will show us the bottom records, right? So last 5 records we would be able to see, right? So because the indexing is starting from 0, so the counting for the rows, it's going 999, right? So this is to see the starting and the ending, or whether our we can say the data is properly readable or not. So this is basically we are doing just the as a first step. The thing is that we are just getting a knowledge about our data set. So the EDA part first is that understanding the data part, right? So what kind of a data it have, right? So we are just printing the different aspect of this data set to see what kind of a record it have, right? So using that pandas data frame, it's more visible, right? So till now we are on the same page, right? We got the same things. Okay. So now what we can do, we can also check the shape of this data sets, what kind of a, how much columns and rows it have. So there is a shape, right? So we can print the shape of this, right? So we have the shape. So it will tell us how many rows and how many columns in our data set. So you can see that 1000 rows we have, and the 5 columns basically we have in our data set, right? So you can see here also 1, 2, 3, 4, 5, right? So till now I am not splitting this data set. Basically what would happen in the predictions part or the modeling part, basically we need to segregate our data profit part out of these all the independent features, right? So we have that dependent features. Based on that, these all are the independent features through which we are defining our profit, right? So till now we are not segregating it at the start. We just want to see what kind of features all they have, right? So we have seen that it has the 1000, we can say the rows and the 5 columns. Now as a next command, this is basically a most important command, right? So we can also describe our data, right? So describe means we can find out some again meaningful expect out of it, right? So for that purpose you need to call the describe function, right? So if I will run this cell, so you can see here some stats part is come to us, right? That is basically the we can say the individual columns wise as well, right? So if you will see here, we are getting count, mean, standard deviations, minimum 25 percentile, that is 50 percentile, 75 percentile, we can say the max, right? So this data is necessary basically to check if you are seeing here, mean is okay, that is average, count is for common for all, Standard deviations for that particular common is okay. Minimum value, we can find out the whatever the minimum value on that particular column. Maximum value, that is the whatever the maximum value on that column. But we have that 25 percentile, 50 percentile, 75 percentile is also there. So that is basically meaningful to check the outliers of from our data, right? So generally that 25 percentile would refer to that quartile 1, that is Q1, right? So 50% is referred to that Q2. Basically, we also call it a median whenever we remove the outliers. So basically 50% we can say the Q2 or the median, right? Or 75 percentile, we refer it with the Q3 or the quartile 3. So basically all these values basically we use whenever we need to deal with the outliers. So at the later part, we would also see that how we can remove the outliers. Basically which are our experimental error or which are not distributed on a normal way, right? So using those values means how we can remove those outliers from our data set. So for that purpose, such kind of a calculations can be helpful for us. So definitely in Python, we are not bothered about the mathematics part. We are just calling the function and we are seeing there and we are directly using those values. But these Q1, Q2, Q3, we can say is necessary to removal of the outliers, right? So this is one of the thing, right? So that is describe part. Next, we can also see the columns part, right? So what kind of a columns we have, right? So we can also print all those columns, right? So this is our columns. So it would print the different columns, whatever we have, right? And next thing is that we can also see the unique values, what kind of a unique values in our, we can say that in the data sets, right? So for that purpose, we have the unique function is there, that is n unique. Through the n unique functions, we can print all those values, right? So that just see that in R&D spend column, we have 997 values are unique, right? So similarly, the administrations and the marketing and the state, we have the three kind of countries are there in that data sets, right? And profit is that we have the 998 unique values under that, and all the values we can say the data type of that integers, right? So this is some other informations, the unique values, whatever we have. Instead of it, we can also go for a specific column as well, right? So we can also check the unique values under a specific column, right? So if I would go for the state, I want to check what kind of unique values I have in the state part, right? So I just give the name of that particular, and there is a unique functions through which we can check what kind of a unique value it have under the state part, right? So if you will just run this cell, so that state column is not in that data set. Right, so here we are able to see that column, but whenever we have described it, it has no existence. So what I do, I would again read that data set, and now I can try to print it. Right, so still we are getting some error on that. So that companies, we have used the same columns, and state, there is a one column that is state, right? So instead of that dot, right? So we don't need to write that dot, right? So now we can run this cell. So we can see that under the state column, basically we have that three unique, we can say the country, that is New York, California, and the Florida, right? So we can also see the unique records by using this unique command under our data sets, right? Similarly, you can also check for the profits or the R&D or the marketing for that part as well, right? Now we can also check because one of the motive of that EDA processing to check the null values in our data sets, right? So if we want to check the null values out of our data set, so we have one function through which we can see that in each column how much null values we have, right? So that is null function is there, and we would do the sum of to get the total count for that for individual we can say the column, right? So just print that cell, that is, you can see that in this data sets we are not getting any null values, means every column is filled with the some values and all, right? But sometimes what happens, we have the null values as well, so we need to decide whether we have to go with that column or not, right? So in that case, what generally what we do, suppose in R&D spend we have the null values, right? We have the more null values. So generally what we do, sometimes we also drop if we have more than 80% null values in that particular column. So we also drop that column, right? So or we generally replace it with the mean median values, that particular columns if it have a less null values. So to deal with the missing value, we just replace it with the mean or the median of that particular columns. We replace the missing values with that. But suppose in this case R&D spend in this data sets, we all have the, we can say the simply we can say no null values are there. But suppose in your data sets you have the null values and you want to drop some column, right? So I am taking another variables because that companies has data sets have no null values. So instead of that, I would store the results in another, we can say the variable, so that our original flow would not be affected by that. So what I am doing, I am creating a new variable, and in that what I want to do, I want to store some results by dropping some particular columns, right? So I want to drop, suppose out of this company's column, I want to drop that state and marketing spend column, right? So I would use the drop functions there, right? And under the drop functions, I would define both the columns, right? So the first column I have, that is state, right? And another column, suppose I want to drop, that is not meaningful to me. Suppose you want to drop that, so you can also put that marketing. We have the marketing that is spent, right? So this is another variables. We have that marketing spend, right? So just quote it under the inverted quotes, right? And we want to drop it column wise. So that's why we define here, that is x is equals to, we can say the 1. 1 means column wise we want to drop it. So we want to drop both the columns. So we have given the x is 1 here, right? So now you can see what we are getting under the data column. So the simple way to print just the head and that part on it, right? So if I print the head of it, I want to print the starting 5 records. So you can see here that both the columns are dropped out of it. So that is sometimes we need whenever it contains the more null values and all, right? So similarly, you can also print the tail of it, right? So data dot tail to check whether your entire file or the CSV file is properly it has done for all the columns or not, means for all the records or not. So just run this one, so we can also get the top bottom records, right? So I hope we are on the same page till now, because till now just we are doing some basic operations. Now after getting all the things, we would also go for the encoding part as well, right? So this is the how we can drop the columns, right? Next part, we would also do some visualizations for our data sets, right? So basically our motive is also to set a relationship, to check the relationship among our variables and all, right? So now we can also visualize our data set. For that purpose, I am going to use one visualizations technique that is known as heat map. So heat map basically is used to check the correlations between the two features or the two variables, right? So here I would use my original data frame variable, that is companies, and for that I would create a heat map for different we can say the to check the correlations between the different variables, right? So here I would use the Seaborn library, and I am going to create a heat map for it, right? And basically heat map is used for to generate the correlations, to check the correlations. So for that companies, I am calling that correlations function. So if you will use correlations functions on the companies, so between the different values, it would create a heat map for you, right? So it's just comparing the correlations using the heat map, right? So we can see what kind of a visualizations we are getting for it, right? So just run this cell, and you can see on the visualizations that it is checking the correlations with each and every features we have, right? So here you can see here that that diagonally columns all are the light color, right? So here you can see the light color means basically the more correlations among the variables. So if you will compare the R&D spend with the R&D spend, so definitely it would be correlated with means R&D with the R&D, there is definitely a correlations between that, right? So similarly, the administration would be if you would find a correlation, so then definitely there would be 100% correlation. So that's why you are in the diagonally, you are getting the highest value, right? But if you want to see like darker means that there is no more correlations, means by seeing this data, you can see that administration and the R&D spend, right? So if you want to find the administrations and the R&D, how much they are related to each other, so you are seeing that the record the value is less than that 0.6, right? So less than 60% they are correlated, right? So darker means the less correlations, lighter we are getting among the variables, so they are much correlated with each other, right? So in this way basically we check the we can say the correlations with the other features as well, and based on that we can also decide whether we have to go for these columns or not, right? So in this case almost they are coming under the 60% or 50% correlated with each other, right? So this is one of the way to check the correlations or to see the dependency of the features with each other, right? Similarly, similar way, we have another that plotting scheme which has that is pair plot, right? So we can also use the pair plot to plot the graphs, right? So that is also comes under the C1. So the method name is that pair plot, and we are just doing the pair plotting for that same data sets which I have stored under the companies part, right? So you can just pass within that function, and you can also see that pair plotting for that, right? So you can see that because we have the 4 columns in this data sets, right? So 4 into 4, it's creating a matrix in that way. If you will take only 2, so it would create a we can say the graph according to that. So 2 features means 2 into 2 matrix it would create. If you have the 4, so it's taking 1 by 1 with each one. So in that way, it's creating that pair plot for that, right? So basically, the most famous, basically we use the scatter plotting because it's shows the distributions of the data, right? So scatter plotting is important out of these, but this is just to create if you want to create some plot on that, right? So again, we have one more plotting scheme, that is relative plot, right? So if you want to plot the graph between only 2 variables, right? So like you want to take only 2 columns, right? So we have the relative plots are there, right? So under the relative plot, you need to mention that your x directions and the y directions. So suppose what you want to put in the x, right? So suppose in the x direction, so I want to put the R&D spend, right? So R&D spend is there, right? So I want to put it into the x-axis, right? So I have given here my x-axis, right? So similarly, I want to plot a relative plot in with the administrations, right? So I want to compare these value using that relative plot, right? So now You can also put the second columns here, right? So that is administrations is there. And other things what you can do for coloring a scheme, right? So for R&D and the administrator data, if you want to distribute it based on some category, right? So we have one parameters there, which is known as hue, right? So that hue parameters would be only that particular value, which is basically the categorical, because it's gives the coloring for that particular records based on the category, right? So if you will see your data sets, you have one category that is a state. In a state, we have the 3 state or the 3 country. So for each country, based on that parameters, you would get some different colors. So that hue parameters can always be a categorical value, right? So, and data, we need to define that we are creating this graph for that companies. We are picking those columns from that companies, right? So this is basically to plot a relative plot between the two, we can say the parameters, right? So that is, we can just run this cell and we can see what kind of a graph it is plotting. So you can see that based on that state, which we have given in the hue parameter, we have the color for that administration and R&D spend, right? So in the different states, between these two, it's created a relative plots for it, right? I hope till now you also have created these graphs parallelly with me, right? So we are moving slowly by typing each and every command, so that you would always you would also be able to see the results and all, right? Just give me a confirmations, yes, no. So that's why instead of showing entire notebook, initially it's a first day, so I am just going in that mode as well, one by one, each command, so we can closely see what kind of results we are getting, right? Okay, so basically this we have the relative plot among two variables, right? So we can also see among the different other plots as well. So one of the plot is that histogram plot, right? So in that histogram plot, basically it's give us a result based on the regions or based on the bins in the histogram we have, right? So whatever the bins we would select, so it would divide your entire distributions among that part, right? So to create a histogram using the, we can say the Seaborn library, we have the distplot function, and in distplot function, suppose I want to see the histogram plot for the administrations, right? So that is for companies, I would pick that column, right? So from that companies data, I want to take that histogram, right? Means that administrations part, that column, right? So what I need to take, I need to take the administrations, right? So I want to create a histogram plot for that particular administrations part, right? So I just defined here that column name, that is companies administrations, right? So we can just see, first run it, right? So you can see here that it has the distributions for that administrations part. In the y-axis, we are getting the density. So if you will see the administrations column, the most of the values are coming between the 10,000s to that we can say in this regions, right, where we are getting all the values, right? So you can also divide it into the bins, right? So bins means if you will suppose give here bin value 10, right? So it would divide your data into the 10 part, right? So in a 10 regions, we can simply say, and now you can try to run it. So it's saying that bin, instead of bin, we need to give here bins, right? So now you can see here, right? So your basically the graph is as compared to the previous one, it's little bit narrow, right? Because we have increased our partitions in that way, right? So means it has divided it into a 10 regions, and based on that, it's showing the distributions in which regions we are getting the distributions for that part, right? So that histogram is plot is there basically to see in which regions we are getting the most of the value for that particular columns, we can say. So this is basically we have that distributions, right? So again, we have one more plotting scheme, right? So that is known as category plot. So if you want to plot the category, right? And generally it also known as the box plot, right? So this is basically helpful to remove the, we can say, the outliers as well, right? So box plot basically is helpful to remove the outliers. So for that purpose, we have the cat plot function is there. So SNS dot, we have the category plot function is there, right? And here we want to see basically for a particular column whether we have some outliers or not, right? So I want to check it again for the administrations column, right? So administrations column, I will set it into the x-axis, right? And what kind of a plot I want? I want a box plot. So I am defining the type of it, that is box, right? So definitely we need to put it in the single inverted quotes as well, right? And next is that we would define data part, right? So data we have, that is companies, right? So if you will so we need to define that data wherever we have read the entire variables, right? So now this would create the category plot for administration. So basically it's a type of, we can say, the box plot, we can say, right? So we can just run this cell and we can see what kind of a plot it can generate, right? So you can see here in this plot, basically we have a box kind of a structure, right? So box kind of a structure means if we have defined something q1, q2, q3, so in the sense of that box plot, that is helpful. So if you will see here, this first line we can denote it with the minimum, right? So basically if I can draw something for you, so what happens basically in the box plot, we have the 5 values, right? So this is known as q1, this is known as q2, or sometimes we also call it the name of median, or you can also refer it with the name of q2, right? And this is our basically the q3, right? So to design a box plot, basically it calculates 5 things, right? So here we have the minimum value, right? So this is minimum, and here we have the maximum value, right? So you would see always the box plot in this form. We have the minimum value, we have the maximum value, we have one median value. This is q1 and q3. That q1 means 25% quartile we have, right? And that is 75%, right? So basically that is for the box plotting out to see the outliers and all. So basically what happens, if you will see in this our problem again, so you can see here that after minimum also we have certain values, and after the maximum also we have certain values, which is basically not a part of it, right? So we basically need to remove those outliers as well, right? So the basic motive to check the box plot is to basically for the removal of the outliers, right? So here this is the outliers which we need to remove, right? So here we basically use one technique that is known as IQR, that is 1.5 IQR we use. That IQR is nothing but first we calculate that IQR value, right? So that IQR value basically we have, that comes by subtracting q3 minus q1, right? So we calculate this q3 minus q1. Basically this is the this regions we generally get by subtracting this, right? So that we calculate that IQR, and then whatever the value we get for the IQR, we multiply it with the 5, right? And based on that, we decide our lower range and then the upper range as well, right? So for the lower range, just we subtract it from the Q1 because we are going for the lower range, right? So this is to set the new bounds after calculating the IQR. The similar way, we for the maximum, we just add it Q3 plus that 1.5 IQR, whatever the value is at. So in this way, we set again the lower and the upper bound for our data sets. So maybe removing those outliers, now minimum would be shifted here for the new values and the maximum would be shifted here for the new values, right? So in this way, basically we remove that outliers out of our data, right? So that is known as that IQR, right? So 1.5 IQR we generally use to remove that. So we have also seen that we have some outliers here in our data set, right? So now to remove those outliers, what we need to do, we need to calculate all these stuff, that is Q3, Q1 and IQR, that subtractions we have done, right? And then we have to set the new values for that, right? So I hope till now it's clear to all of you, right? So you are on the same page with me, right? Okay, so what next step we want to do? So you can also check for the individual columns as well. These kind of things for which we have the outliers or we don't have the outliers, right? So now what we have to remove the outliers out of it. So I am using here one directly the code we can say to remove those outliers instead of going for one by one for it, right? So you can see here that Q1 is basically the 25 percentile, right? Q3 would go under the 75 percentile. So first of all, we are calculating that IQR, right? So IQR, I simply said that Q3 minus Q1. Now we are defining our upper and lower bound, right? So upper and lower bound means we are using here 1.5 IQR and we are using it on the Q3 to set our new upper bound, right? And similar way, for the lower bound, we are subtracting it from the Q1, right? So I have printed here old shape as well as the new shape. So how we would come to know that some data we are able to remove or we have removed the outliers or not, right? So we would print the old shape and we would also print the our new shape out of this data, right? And just we can also again plot that SNS box plot or the plot which we have plotted previously to see whether we are able to remove those outliers or not, right? So this is we can try to run this and you can see that by setting all these 1.5 IQR that technique, we are able to remove that outliers. Yeah, definitely there is one outlier, but mostly we have removed as compared to previously, right? So and if we will check with the old shape here, so initially it was the 1000 records, right? So in our initial data sets, we have the 1000 rows and 5 columns. Now removing the outliers for that administrations, now we have 978. So it means we have removed some outliers out of our data, right? So this is the thing. So similarly, I am also putting, yeah, that code if you are using the same. So I am also putting this code into the chat window, so you can also check with our your system as well, right? That removal of that how we are removing that we can say the outliers. So this is one of the scheme through which basically we are removing the outliers, right? So sometimes it is also necessary to remove the outliers, right? So if you have seen till now, so we have just seen the our data in the different aspects only, right? So we have not gone for any that maybe some of you are familiar with the machine learnings implemented, right? So till now we have just seen our data using different functions and different visualizations, right? So still we are pending with our that encoding schemes as well, because in our data sets we have the state column, which is basically string value, right? So now we would just try to create our data for the modeling perspective now, right? So we would create a variables in this way, right? So which would be helpful for the modeling part as well, right? So now what I am doing for the modeling perspective, I am segregating my dependent and the independent variables out of my data set. So till now we have seen such kind of a records, right? So in by analyzing these data sets, you can also see that there is no null value, but string values are there that we have to deal with, right? So first of all, I want to divide my data sets into the dependent and the independent variables, right? So definitely that dependent means whatever our output variables, right? So in X, rest of the columns would go into the, we can say the X, right? So for that purpose, I am going to use the index locations function, right? So using the index location functions, what I would do, I would just segregate my independent and the dependent variables. So here I am using that index location, that is I location, right? And here I would give the range, right? So here as a first parameter, I am passing nothing. I have just given the blank, and in the second columns I am saying that as a range, right? I am saying that range -1, right? So this values I need, I just explaining if someone is not able to recognize it, right? So basically this is the range function, range in Python, right? So I have just given the range sign here. I have not given the initial position and the ending positions here, right? It means starting and ending, there is nothing. So this first parameter basically for the rows, if I have not given any initial and ending positions, it means in X I want all the rows. So this first parameter without any starting or ending positions will cover all the rows, right? And in the second parameter basically we use for the columns, right? So here if you will see, starting positions is nothing, so it would take the column value starting from the 0th index positions, and it would go for the -1. -1 generally refer to the last column, right? But in the index locations or in the range, right, whatever the ending positions we give, that is excluded, always excluded. Suppose I am giving here 2 to 4, right? So it would take the columns from 2 to 4, but it would not take the fourth column because that ending positions would be always excluded, right? So what I am doing in the X or the independent variables, I am taking all the rows, and from the starting columns, 0th columns, to the before the previous last column, whatever we have, right? So we are not taking the last column because this is for our Y, this is our output, right? So similar way, we can also define our Y, right? Y means our final output column. So if you will take that final column, so again we need to use that index locations function, and in the range I want it for all the rows, right? And in the column, what I need to give, I don't need to give any range. I can directly say that -1 columns I need, right? So because no need to give the range here, because only one columns we have to give as a output, right? We want to define as a output, right? Or instead of that -1, what you can do, you can also give the index positions directly 4 also to it, right? So if you will see our data set again, if we would go in the original data set, right? Yes. So this is the 0th index positions column. This is 1, this is 2, this is 3, and this is 4. So instead of -1 also, you can also give the direct index positions 4 to it, right? So it will fetch the same data out of it, right? So what we are doing here, we can also give, because we have already seen the -1 usage of -1 there in the X, right? So in the Y, we can directly give the 4 here, right? And then just values, right? So now we can just run this cell and we can check, try for the error, right? So we can also now print individually X and Y, what kind of a value we have, right? So you can see here that starting 4 columns are moving into the X, and the last column would be segregated into the Y, right? So this Y is the profit, that last column, and the starting X, we have all the 4 columns are there, right? So in this way, we have segregated our X and Y instead of dealing with entire data. Because if you will see now in the X, what we have that state, right? So that is string values is there. So we also need to follow the encoding scheme now here before putting it to our any training part or something, right? So that New York is the state, right? So I am also pasting this code, so you can also just split quickly your data into the, we can say, the X and Y, right? So that we got the X and Y. Now we are dealing with the string values. So we have segregated. Now string values comes under the X part, right? So now we would deal it with, and for that purpose, I would use that basically the, we can say, label encoding as well as one hot encoding schemes I would use for it, right? So that we can see the usage of both, right? So first, what I would do, I would convert it into a integer, right? So integer value, and then I would convert it into the binary value using the one hot encoding scheme. So I want to show the usage of both the things, label encoding as well as we have the one hot encoding scheme as well, right? So first of all, we can see the label encoding, how we need to do. So for that purpose, we need one more library, that is skitelearn. So that also need to be installed on your system, right? So I am just calling that skitelearn library, right? And from that skitelearn, we need a sub module that is known as pre-processing, right? Because we are dealing with that pre-processing with the data, right? And I want to import both the encoders from there, both the classes for the encoding, right? One is that label encoder, and another we have the one hot encoder, right? So for the classes, the convention is same here like we do in the Java or the other programming languages, right? So initial alphabets is the capital, right? So label encoder. So initial alphabet for both the classes are capitals here, right? So these are the classes which we will use for the label encoding, right? Now the same way we would create an object for label encoder class first, right? So here what we can do, we can create an object for the label encoder, right? So here we are just creating an instance for it, label encoder, and this is just a object of this particular class, that is label encoder, right? So we have created an object for it. Now with the help of that object, we would fit it into a particular columns, right? So if you would see here in the X, that would come into the 0th index, 1 index positions, 2 index positions, and in the 3rd index positions. It means we need to change in the X in the 3rd index positions, right? So here, according to that, we would give the, we can say, the value, or we will select the particular columns, right? So what we want to do in the X, we want it for all the rows again, and as a column, we want to select the 3rd column out of X. We want to do the conversion on it, right? So now you can fit this label encoder to that, right? So we have created already the instance, right? Using the fit functions, fit, and one more is there, that is transform. What happens generally if you deal with the machine learning, so basically we have the fit or predict function, but if you will see in the case of label encoding schemes, we are using one fit transform function. Basically it is calculating and converting the value in the same time, right? So we are doing the fitting, means whatever the necessary we need, we are doing that calculations, and we are doing the replacement in a single function, that is fit transform, right? So under that, just we need to give the we can say the for which converting it, right? So here this is the we want to do the fit transform for that particular, right? So we can more see to fit transform function. Basically, what is that? Whenever we were discussing about that feature scaling part, so you can see here to normalize the value. What happens generally? We need minimum value, maximum value, and minimum value. So all these calculations is done by generally the fit function, and whatever the final value you are getting after the replacement, that is done by the transform function. But in the case of label encoding, we have both the things simultaneously. We are also calculating the things, we are getting the final replacement value using that fit transform function, right? So now what we can do, we can just run this cell as well. It's from, we already put the dot here, right? So just remove that dot. Now try to run it, right? So it's successfully run. So we can also print again the X, right? So you can see here the last column is converted corresponding to integers value. Here it's 2, then 1, that 2. So what basically the label encoding do? It assigns integers value to the different items we have simply, right? So we have 3 states, so it's given 0, 1, 2, 3 value. Starting from the 0, 1, 2, 3 value, it's given, right? But now what we want to do, we want to also use the one hot encoding schemes for our, we can say the we want to utilize the same things for there as well, right? So for one hot encoding, what it will do, it will convert these values into the binary equivalent as well, right? So for that purpose, we would again use that we can say 2 more classes we would use. One is that column transformer, and one hot encoder we have already imported here. So what we need to import more from the Skytand library, right? So from this library, we need to call one more sub module that is known as compose. So that column transformer class resides under that compose function, right? So from there, what we would import that, we can say the column transformer class, right? Column transformer. So this is the class which is basically useful for the one hot encoding, that column transformer, right? So now what we need to do again, we have already imported that one hot encoder class, right? So we need these 2 classes, column transformer and one hot encoder, right? So now first of all, we would create a object for that one hot encoder class, right? So what we are doing here, we would use some parameters for that one hot encoder, right? So as an object and as a parameter, we need to pass some values here, right? So I have taken it, right? So for column transformer, while we are creating an object for column transformer, we have basically the 2 parameters. One is that transformer and another is that remainder, right? So 2 parameters, basically it consists that column transformer class. In the transformer, basically we define that we want to doing the encoding. So that's why we pass the encoder. We want to use the one hot encoding scheme, and we mention the value for which columns we want to convert it into a binary equivalent, right? And another parameters, that is remainder. Remainder equals to pass through means we should not go for the other columns, just bypass those columns, right? So that's why remainder equals to pass through, right? Because we just want to convert this value, integer value on the 3rd column into the binary equivalent, right? So this is basically the thing. Now we would get a new value on our X variables, right? So again, we need to call the fit transform function, right? So we would apply that fit transform function again, right? So that is fit transform, and we need to fit it on the, we can say simply X, right? So we would define here again our, we can say the X value, right? So this is the function, and in this function, we are going to pass that X, right? And parallelly, what we can do, we can also convert it into a array, right? So most of the times what we do, we convert our multi-dimensional array into the single dimensional array that you would see whenever we would go for the CNN applications, right? Because the fourth layer, we have the flattening layer there, and whatever the value we have from the individual inputs, we flatten it into a single layers, right? So here also we are just doing the convergence for that, right? So here I need to check the brackets again, right? So this is for X and one for that transform, right? So this is our new X, we can say, after doing the encoding schemes, right? So just take this. Okay, so now we can run this, and after that we would print our X variables as well, right? So now again we can check our next updated X variables by printing this, right? So you can see here that that state columns is now converted into the in this way. Whatever the first row we have, that is converted into the 001, second is 01110, and the third category we have the, we can say, 100. So these for three countries, it has created the three variations according to that, right? So for label encoding as well as for the one hot encoding schemes, I am just placing both the codes, so you can also utilize the same things, right? So for this is for label encoding, and this is for which you can apply for the one hot encoding, right? So you can see here now that integers value again is converted into the binary value, right? So here again we can also utilize that dummy encoding schemes as well. So what we can do, we can also drop out of whatever we got here, right? So we can also drop our first columns out of it, because if you will see, 01 is there, right? 10 is there, and 00 is there. If we are able to differentiate all the category using these only two columns, we can say, so we can also take the advantage of that dummy encoding as well, right? So for dummy encoding, we just do not need to do a lot of things, right? We will just set the new index positions, right? So here what we will do, we will just, for all the columns I want, and what I want from 1 to remaining, means all the columns from the first index positions I want to pick, right? So I have just set here the index position. So what does it mean? That first parameter means for all the rows I have to do, and I want to drop my first column. So that's why instead of taking the 0 index positions, I have taken the 1 index positions here. So I want from this columns to the last columns into the X. So I am just removing to take the advantage of that dummy encoding, right? So I have removed this column. So that's why the index positions, starting index positions is from 1 up to the last, right? So this is now our new X, which we would use for the further processing, right? So you can also print this one, this X again, what kind of a value it consists, right? So you can see that here we have the 3 columns, but now we have removed that 1 column from there as well, right? So this is our X, the new X, right? Now the next things we can do, we can also do the splitting of it, right? So what happens in the machine learning, whenever we would go for the modeling part from the next sessions onward, so we also need to do the splitting into the training and the testing part, right? So here we have one sub modules under the sklearn, that is model selection, right? So what we will do from sklearn, we will use the model selection, that model underscore selection. So model dot selections we are going to use for the splitting, right? And one method is used here, that is train test split, right? So that is train underscore that is test, and underscore that is split. So this is the method which we need to use for the splitting our x and y, right? So that is train test split. Now, what we are doing here, we would divide our x and y into the 4 parts, right? So we would divide our x and y into the 4 parts, right? So if you will see here, that is x and y, how we can divide it. Okay, so here we have the x and we have the corresponding y value, right? So in the y we have the profit, and in the x we have the rest of the 4 columns, right? So now what we will do, we will divide that x into the 2 part. Suppose we have 1000 records, we have 1000 rows, right? So we would divide that x into the 2 part. That is, one part is that x train, right? And the remaining records for the x part, that is x test, right? Similarly, we would divide that y into the 2 part. This part would become under the y train, and this part would become under the y test, right? So what we are doing, we are again dividing our x into the 2 part, that is the x train and the x test, and we are dividing our y into again y train and the y test. So why we are doing? Because this x train and the y train we needed, this combined thing we needed for the training part. Whenever we will train our model, this complete things we need for the training part, x train and the y train, right? And x test we will use to check the results, or to check the performance of our we can say the model. We would feed this one to our trained model, right? So our model would give us some predictions, and whatever the predictions we would get, then we would check it with the this original y test value, right? So the model would give us some value, that is y prediction, we can say y predictions, and we have already the actual results for with us, right? So we would compare that with the y actual or the y test, whatever we have here, right? So the whatever the gap or the results for that as evaluations matrix, we will use according to our classifications, regressions, or the based on the model. So we would compare both these things to check the results for our model, right? So that's why we are just splitting that x and y into the 4 part, right? So here what we need to do, we just need to split it into the 4 parts: x train, x test, y train, and the we can say the y test as well, right? So if you will see, so this is the 4 part, that is x train, x test, y train, y test. How we are splitting it? We are splitting x and y into the 4 part. Text size we have taken 0.2, means 20% we want into the test, and 80% we want into the train part, right? And we have taken here some random state value. We also take it 42, but the motive is to take the random state value is that because it's doing the random splitting of the data, right? So suppose you will not set some random state value, and if you will get the this code again tomorrow without any random state value, so it would create a different splitting for you, right? Because the splitting is being randomly, right? So to prevent that, if you want to operate with the same x train, y train, y test values, right? So you can specify some random state value there, so that tomorrow as well you can get some results, same results as a splitting, right? So now what we can do, we can just print, or we can run this cell, right? And we can also check the individually, because we have split it into the 80-20%, 80 in the train and the 20% in the test. So that x train, if we will see by printing it, right? So that is the starting, we can say the 80-100 records out of 1000, right? So similarly way, if you will go for the test part, so remaining 200 rows would go onto the x test part, right? So you can also print that for the 200 rows, because our total size is 1000 rows, right? So we are splitting it into 80-20%. So 800 would go into the training part and the remaining would go on to the test part. Similarly, we can also print this Y train and the Y test, right? So we can print this Y train. So similarly, in the Y train, we would get the starting 800 records, right? And if we would go for the Y test part, right? So in the Y test also, we have the 200 records, right? So that we can check whether we are able to print or not, right? So for your practice as well, I am just pasting this code for the splitting. So you can also check this thing with your data sets, right? So this is how we are splitting. Now what in the upcoming sessions, what we are going to use, we are going to use this extend whitens for machine learning algorithms, right? So now whatever we have done, we would feed this one to the machine learning algorithm, right? So that may be anything in the form of regressions and the form of classifications, or in the form of unsupervised learning, or maybe other algorithm, other approach, whatever you are following, right? So we would feed this data to that training part, and after the training, then we would get predictions for that X test, and we would compare this whatever the predicted value we have with the Y test value for the evaluation. So for classifications and the regressions, we have the different evaluation schemes that are not common for all, right? For both the algorithm. So that we would use evaluations criteria, right? So these sessions, because we basically basic things, libraries, and how we can analyze, how we can split, and next things we would use in the upcoming sessions in the form of algorithm, right? So from my side, it's done. So now if you have any queries, so you can ask. Yeah, so basically one query is there, pair plotting is that. So pair plotting, as the name is suggesting, that we are just drawing each and everything with the right, we have the 4, right? So in here you can see that in the x-axis we have the 4 columns, right? And in the y-axis, x-axis and the y-axis, we have the 4 into 4 matrix, because we have 4 into 4 columns in the both sides, right? So if you go for only for the 2 columns, random that R&D spend and the administration, so it would also take only the 2 parameters, as the name suggesting that we are just checking with each pair, right? So what kind of a relationship or the distributions it is showing that, right? So basically for that purpose we are using the pair plot is there, right? But most probably for the distributions point of view, we use this we can say the scatter plot to see the distributions of the data. So here we have seen these things in the scatter plot, right? So most popular approach is this one, that is scatter plot. So generally we refer this scatter plot because it's show us the clear pictures where basically our data is, whether outliers in which regions and all, for which data it have, right? So in this way we conclude. I hope it's clear to you, right?
Okay, Alok, thank you so much for such a wonderful session. I believe your content is over.
Yes, Kathy, it's now done.
Okay, thank you, Alok. Dear faculty members, I have shared one attendance link in the chat box. Those who have filled the attendance, that is fine. You can ignore the message. However, remaining faculty members, please fill in your attendance. the attendance link will be available till 4:15 only. After that, it will not be available. We will close the link. So request you all to please mark your attendance for today's session. And I will be providing you the recording of this session by tomorrow in the WhatsApp group itself. If you have any doubts right now related to you can ask your queries in the WhatsApp group also while coding or while practicing the same code. You can, if you feel any doubt or query, if you have, you can mention that in WhatsApp group also. I'll add Alok to the WhatsApp group. Do we have any queries right now?
No, madam.
Ma'am, at what time tomorrow we'll be having this?
So same timing will be there for 5 days.
From 2
to
from
4.
2 onwards, na? Every day from
Yes,
2,
sir.
na?
Yes,
Thank you, ma'am.
yes, sir. Okay.
Madam, I have one question.
So Alok, can you
Yeah.
provide
Hello,
the
madam.
EDA
Hello?
PDF?
Hello, can you hear me?
Yes, sir.
I have one query.
Yes, sir.
Madam, could you give any like other examples like case study kind of exercises?
So, sir, your voice is not clear.
No. Could you provide any case study examples?
Okay. Alok, do you have any case studies example like from where they can practice or
No, Sarah has
can you
given
provide the
simple.
code or EDA file so that they could practice?
Like for example, domain, banking domain, like any kind of domain exercises, case study kind of exercise. Then we'll go through it, we'll solve it. General examples Sarah has given, that is nice. So I'm expecting like case study kind of examples, like banking
Okay,
sector,
okay.
insurance domain,
Okay, sir.
any other
Alok,
domain
do you
related
want to take this?
exercise. Hello, sir. I'm audible, sir.
Sir, you're audible. I believe he was having some internet connection, so he got dropped off. I'll inform him to share some case studies in the WhatsApp group itself.
Yeah, if you provide in the chat also, we are very happy, madam.
Yes, sir. For sure, I'll ask him to share that.
Thank you. Thank you.
Thank you, sir. Okay, so if we do not have more queries, can we conclude the session here? Okay, I'm sharing the attendance link again in the chat box. Alok, you're there?
Yes, Kathy, I was just disconnected. So yeah, I have
Okay,
rejoined.
so few faculty members want some case studies for practice, like from any domain. Can you provide those in the WhatsApp group itself?
Yes, I have some case study, like we have one iris datasets, which is the most popular for doing this kind of study. So I would also attach that Jupyter notebooks with the more
Sir.
plots. You can also, yeah.
Sir, like because that is a built-in data set which is available in scikit-learn, other than the data set which is not available in the scikit-learn.
Yes, sir, definitely we can create our own data sets as well.
No,
If you
sir,
are
sir, what
okay.
I'm asking is, so the
Yes, sir.
data set which you said, iris data set is available in the scikit-learn data library. So other than
Yes.
that, do we have any other like case studies?
Yes, definitely I would provide some data sets for that. You can follow the same EDA processing for that.
Yeah,
So
case
I would
study
share it.
data set,
Yes.
case study data set. The case study in the sense problem statement.
Yes. So definitely, if there is any data set, so this is for some problems, right? So there is the input and the output as well. So we can do the EDA processing for that, right? Yes.
Okay. Thank you, sir.
Okay, everyone. So thank you so much for your time. Let's meet tomorrow at the same time, and we will have another session. We will have another expert from industry who will let you know about more about the technology, and we will have another hands-on session tomorrow. So I'll just copy paste the prerequisites again in the WhatsApp group also for your convenience. Uh, so I'll provide the recording also by tomorrow morning. Thank you everyone for joining in. Thank you so much for your time. Thank you, Alok, for such a wonderful session. Have a nice day, everyone.
Yeah, thanks to all.
Thank you.